Okay, so this is where we left off in the last video. I left you on this screen, and the questions were, what does the 6 indicate? What does the 12.1 indicate? So hopefully you had a chance to think about that. And the 6, of course, is the number of protons, which defines carbon as being carbon and not something else. The 12.01 is going to be the mass. And so let's go back. Let me click in here. So we have our relative atomic mass. Bring this down here from the periodic table of 12.01. And then again, every element has a unique atomic number and a unique relative atomic mass. That relative atomic mass, if you've forgotten, is the average of all the isotopes. So that's all the different neutrons that could be possible in an atom, averaged out. But today, we're going to use that same number and we're going to call that the molar mass, which is where this mole concept really becomes handy because the mass in grams of 1 mole of any pure substance is the same as that number. It's the same as the relative atomic mass, but we're going to actually use the unit gram when we discuss it. So our units here are grams per mole, and that -1 here means this goes to the bottom of our fraction, so grams per mole. So this means that hydrogen has a mass of 1.01 grams per mole. Okay, so why does this matter? Well, let's apply it to some examples. 1 mole of carbon, 12.01 grams. 1 mole of magnesium, 24.31 grams. 1 mole of copper, 63.55 grams. And here we are. All of those come directly from your periodic table. Okay. So this brings us to the part that's maybe a little tricky, but also more meaningful than some of the stuff that we were just talking about, which is if we have a sample and we know its mass because we can put it on a balance, then we can determine how many atoms might be present. So since 1 mole of carbon is equal to 12.01 grams, we could flip that either way and we can make conversion factors to convert between mass and moles. So here's a question. If we have 65.5 grams of carbon, how many moles would that be? So I'd like to challenge you to just try it out. See if you can figure out the right conversion factor to use. Punch it into your calculator and see what you come up with. So pause the video, pause me, see if you can get to the right answer, and then you can verify with the work that I'll show you on my screen in just a second. Oh, sorry, I'm a Dora the Explorer kind of video now. Sorry. So you can just take a second and here's the work for me. I took 65.5 grams. This is my conversion factor because we want to get rid of grams and convert to moles. Therefore, we want grams at the beginning here and then grams in the denominator here. So the grams will cancel out. And 1 mole of carbon is equal to 12.01 grams of carbon. And we got that from the periodic table. We do our little division, and that tells us that 65.5 grams of carbon is equal to 5.45 moles of carbon. And then we could take that number and we could use Avogadro's number to talk about how many atoms of carbon that might be if we wanted to do that. So if we go back to this little schematic that we had before, we can now add mass to the whole situation. So we know we can convert between moles and the number of particles. We did that already, and we can keep going. And now we can convert between moles and mass pretty easily using our molar mass taken from the periodic table. So molar mass in grams is straight off the table. And then we can use that to convert between mass in grams and moles. Excuse me. And we can even start with mass and then set up 2 conversion factors to get to the number of atoms present. And that's exactly what we're going to do now. So what if we had a question like this? What is the mass of 0.725? First, of course, we have to reference our periodic table to get this set up. So we find argon on our periodic table, and it is 39.95. And we find our conversion factor, right? So our conversion factor will be 39.95 is equal to 1 mole. The question said 0.725 moles of argon. We make sure we set it up so that the moles are on opposite sides of the fraction. And if you don't know what I'm talking about when I say opposite sides of the fraction, just keep in mind that this is the same thing as putting this over 1. Because you divide anything by 1, you get the same number. So this is the numerator, this is the denominator. The moles cancel out. The question asks us for mass, and here's our mass, 29.0 grams of argon. Make sense? I hope so. Cool. Okay. Now we have to do a little bit of an extra step here. So what is the mass of 5.31 times 10 to the 23rd atoms? Not moles, but atoms. So now we're starting with particles. Then we have to do a molar conversion. Then we do a mass conversion. Okay, so again, we're going to start by setting up our mole conversion. Then we go to our periodic table to get our mass conversion, and then we're done. So I'm going to put this over to the side. We've got our molar mass of copper up there and ready to go. We set up our 2 conversion factors, and we can put them both into one nice expression, knock out both conversions in one expression. So to make sure everything cancels right, I'm going to get my pen back out. And so we start with atoms, and we want to convert from atoms to moles. So atoms would be on top of the fraction here, because remember, it's the same as being over 1. So atoms cancel. Cool. Then moles will cancel in our next conversion factor. And that brings us to our final mass, and we're left with grams, and that's what we wanted. And then we're done. And in case you missed it, let me move myself. Oh, it's not there. We got this conversion for copper directly from the periodic table. So atoms to moles, and then moles to mass, and now we're at grams, and we're good. Okay. So that's the end. These notes are posted on ManageBack. So they're available to you to review. Of course, use the video as needed. The one thing that we're changing today is we are not going to do the mini lab because, because I am not here to run it with you. And so mini lab is out. So all you need to do to finish class today is your homework assignment, which the substitute will have for you. So if you didn't get your homework assignment yet, go see the substitute right now, get your worksheet, and we're just going to do worksheet 1, which is moles of elements. And that's it. I hope this helped. I hope you did okay. Come to class prepared next time with questions on anything that did not stick. And I look forward to seeing you next week. Again, see, this is just so much fun. So much